All right, let's take a look at a few things about graphs here. We're going to be doing some graphs today. And the first thing is when we plot our data points, let me put in a few here. Now, these are relatively easy to see, but if you're graphing them with maybe some pencil and you just put a dot there, it's very difficult for me to see that. A graph is a visual tool that we use in science. We can basically look at a graph and we get an idea about the relationship between the variables involved just by looking at it visually. So we want it to be easy to use visually. And so the one thing I would say is that it's nice to have maybe a little circle around these dots so we can more easily see it. Again, particularly if we're making a dot with a pencil or pen here. Also, it's nice to use color. If we have color in the lab, I definitely recommend that. And so I would do something that looks like this. All right, that makes our data points very easy for us to visualize. And let's take a look. Let me just make another separate graph here. All right, and so I would do something that looks like this. And one thing that we're going to want to observe with almost all the graphs that we do in this class, the first question is the graph linear or not? All right, does it follow it? Do the points follow a straight line, or is there some curve to it? Now, this one here, to me, that looks pretty linear. And not only when we look at our data points, but we should also think about what we're measuring, and does it seem correct that the relationship is linear? If this is the case, if you believe that it is linear, then we're going to often want to draw in what's called a best fit straight line. All right, a best fit straight line. And so we would, well, I don't have one here, but we would want to use a ruler, and we'll have those available. And using your ruler, you want to make one line that overall is as close as possible to all of these lines. And so if I did that, I would get something that looks like this. All right. And the nice thing about when we get this linear relationship is a lot of times we're going to be looking at the slope here, and the slope will have some information for us. Now, in this graph, if it doesn't look linear, and maybe if we don't expect the graph to be linear, then I don't think we should draw in a best fit straight line because it doesn't look like it's a linear relationship. And I also wouldn't really recommend just connecting the dots here. I would say make an attempt at a best fit curve. And so this is really just freehand, and see we're just going to kind of approximate how the curve looks like there. All right, so a couple other things. A lot of times we're going to have a question that says describe the shape of the graph. And so a couple of things that we're going to always want to talk about is the slope, would maybe be one. Okay, so we saw that this would be a positive slope. If the graph went downward, that would be a negative slope. And a zero slope, our points would look something like this. So this, I would say, the shape is linear with a positive slope. This, I would say, this graph has a positive slope, but the slope is increasing. Right? Look at the slope; it's becoming angled more up in this example. And so that's how I would describe the shape here. And I think two more things here. We're going to be looking at a couple of the graphs that we're going to be looking at in this lab are our position versus time and velocity versus time graphs. And, well, I don't necessarily want to draw those in for you. I want you to look at your data points. But it turns out that in the position versus time graph, the slope is the velocity. The slope is the velocity of the object. And so, we'll take a look at that. In the velocity versus time graph, the slope equals the acceleration. And so in both of these graphs, we're going to be looking at the slope and try to get some information about the velocity and try to get some information about the acceleration here.